Okay, we're looking at number 14, and it's the challenge problem. And it says that ZYQ is equal to 45, and ZQP is equal to 45. And it wants us to prove that ZQR, so ZQR, is congruent to XYQ. Okay, so XYQ and ZQR and the two 45-degree angles. Measure of angle ZYQ is equal to 45. The measure of angle ZQP is equal to 45. That's given. I can also say that angle ZYQ is a linear pair with XYQ. Do the same thing with the ZQP. And ZQR. And that's given from the diagram. Okay, so we've got both of these are linear pairs, so we could also say that ZYQ and XYQ are supplements. And I'm running out of room here. ZQP and angle ZQR are supplements, and that's the linear pair postulate. And if they're supplements, we've got angles that are supplements. They're supplements to angles that are equal. Okay, so they're equal, let's make them congruent. So we can say that angle ZYQ is congruent to angle ZQP. And getting a little bit crowded here. So this is step 4. And step 4, the reason we said is because we showed, oh no, I can't show that. Skip that step. Because first I have to show that their measures are equal. So I can say that the measure of angle ZYQ is equal to the measure of angle ZQP, and that's just the transitive property. Okay, so once the equal, now I can do ZYQ congruent ZQP. That's the definition of congruent angles. I've got angles up here that are supplements with congruent angles. So therefore I can say that angle ZQR and angle XYQ are congruent because of the congruent supplements theorem. Alright, here we're trying to prove that BE and CF are the same, are congruent. So maybe we could do that by equal length. We've got a bunch of congruent segments, so BA and BC are congruent, BC and CD are congruent, and AE and DF are congruent with each other. So these three are congruent to each other, that's 2. BA is congruent to BC. BC is congruent to CD. And segment AE is congruent to segment DF. That's given. So I can say that BA is congruent to CD. So BA and CD, that wasn't shown before, BA and CD, because of transitive property of congruence. And now I can show that the segment addition, I know that BE is equal to BA plus AE, and CF is equal to CD plus DF. And that's the segment addition postulate. So somehow I'd like to get these two things set up equal to each other. So I need a BA and an AE, CD, DF. I've got all these congruent segments. Let's make some equal measures. So I can say that measure BA is equal to measure CD, because I showed they're congruent here, so their lengths are equal. I need AA and DF. Those are also congruent, so I can say that length AE is equal to length DF. And that's just the definition of congruent segments. And if I add equals to equals, I get equals. So BA plus AE equals CD plus DF. That's just the addition property of equality. And now, of course, I've got what I need to substitute back in. So now I can say that length BE is equal to length CF and if the lengths are equal, then the corresponding segments are congruent. And I'll leave, is this the last one, or I got two more? Last one, we'll try and finish it up. Okay, so EH is congruent to GH. Not that one, but this one, so that's hard to mark. And FG is congruent to GH. And prove that FG is congruent to EH. Okay, well, luckily this one doesn't look too bad. EH is congruent to GH. FG is congruent to GH. Okay, so, and I need to prove FG and EH. That's one stepper. FG is congruent to EH. You know why? If A is congruent to B, B is congruent to C, then A is congruent to C. Alright. So this was given, and this is the transitive property of congruence. And that's it. Hope you had fun working through these. Again, I hope you work through them mostly by yourself, because that's the only way to learn them. If you ever forget them, come back. Maybe you find a more efficient way to do some of these than I did, which would be great. In that case, share them with the class, and maybe we can include your video in here. Good luck.